Hi guys, and welcome back. So in this video, what we're going to do is set up a few virtual machines in the cloud for us to set up our etcd cluster on. So I'm going to be using Amazon Web Services, the Elastic Compute Cloud or EC2 service here, but the EC2 service is really just a service that allows you to spin up virtual machines. They just happen to call them instances in AWS, but if you're using a different cloud platform, go ahead and just follow the steps for your particular cloud vendor. So if you are using AWS, then we can go ahead and just follow along in this particular video. So I'm going to go down to instances here, and you can see I've got these three orphaned instances that are all in the terminated state. This is where I did my initial testing on to ensure that the Kubernetes documentation was actually reliable and that the steps were easy to understand and actually work with the expected outcome. So what I'm going to do is just hit launch instances here. And remember that we're going to be creating three virtual machines, not just one, not just two, but we need to make sure that we have three for high availability. And one of the things that you might want to do is actually split these across multiple availability zones within a given region. So if your cloud vendor has, the concept of regions and availability zones, then you could create each virtual machine in a separate availability zone. And that way, if any of the availability zones within that particular region went offline, then you would be able to continue operating your etcd cluster because you still have virtual machines running in other availability zones. You could even take that a step further, and you could actually create an etcd cluster that spans multiple regions. So even if an entire region, like US West 2, were to disappear off the Earth, then another region where you have instances running in the same cluster, maybe US East 2, for example, or maybe you've got some nodes running over in a European region, for example. As long as you have nodes running in a different region, then your etcd cluster will continue to operate. Of course, your load balancers would need to be configured to load balance traffic across the nodes, and you could also use something like DNS-based load balancing to spread traffic across regions as well. That's kind of beyond the scope for this particular skill, but I did at least want to mention that as you are going through and building out a production quality etcd cluster, it may actually make sense to plan some of those additional factors like availability zones and regions into your solution. So I'm going to be using the Ubuntu server image here. You could, of course, use other distributions of Linux as well, but the steps may vary a little bit depending on which distribution you're using. And the Kubernetes documentation for the high availability clusters with etcd actually uses Ubuntu in here. So if we just do a Control F and search for Ubuntu, you can see that they're actually referencing an Ubuntu user account. And it just so happens that the Ubuntu image on AWS has a default user account of Ubuntu, and the file system paths all kind of match up with what you'd expect on a typical Ubuntu system. So I am going to be using Ubuntu Linux for this particular demo. All right, so I'm going to choose Ubuntu 20.04 LTS, which is the latest long-term support or LTS version of Ubuntu. And then once we choose that image that we want to deploy as our operating system, we can choose which instance type, and your cloud vendor might call this something a little bit different. It just happens that the instance type is the number of virtual CPUs and the amount of memory and the storage and network performance. So I'm going to use what's known as a burstable class, which is a fairly inexpensive class of virtual machine in AWS called the T3 series or T3 family of virtual machines. And then I'm just going to use a relatively small one called the micro instance type that just has 2 vCPUs and 1 gig of memory. And that should be plenty for creating a sample etcd cluster. However, if you're building a production cluster, you might want to look at a larger instance type, maybe something that has 2 or 4 virtual CPUs and a little bit more memory as well. So let's choose T3 micro for now, and then we'll go to instance details. And I'm going to plug in that I want 3 instances. And so this is going to use this wizard with all the settings that I've plugged in, like my operating system and my instance type and any network configuration options that I use here. And it's just going to kind of replicate that across 3 different instances here. And then I'm also going to check off this box here called Request Spot Instances, and that helps me to just save on hourly spend. This is really good for dev systems, but not for production systems, because AWS can reclaim the virtual machine capacity for other customers to deploy at any moment. So I think it should be pretty safe to use that for this particular dev demonstration, since it's kind of a short-term cluster. I'm going to go ahead and just use my default virtual private cloud here, and I'm not going to set a preference for which subnet and availability zone I'm going to deploy these instances into. I'm also going to ensure that all of the instances have a public IPv4 address so that I can SSH into them across the internet and install the necessary software components on each of them. All right, so that's pretty much all we need for the basic VM options. We don't really need anything super special. I'm going to go ahead and just bump up my storage to maybe 10 gigs of storage just to make sure I have enough. And then on your firewall rules, or security groups they call them in AWS, we want to make sure that we have a security group or firewall that allows inbound access on TCP port 22, and that's just for cluster administration or SSH. And then we also want to make sure that we have another TCP rule that allows inbound access on port 2379 and 2380. Now, after the security group has been created, you can edit the rules later on and change the source to only have inbound connectivity from other security groups that are part of the same VPC, but that's kind of beyond the scope of this particular training. All right, so now that we've got all of our configuration options set up, let's go ahead and launch these. And I'm just going to go ahead and create a new SSH key pair here. And I'm just going to call this etcd key pair. And I'll hit download to download the private key for that key pair onto my local file system so that I can use that private key to connect to each of these instances using the SSH CLI tool. Great, so now we've got these 3 virtual machines that are launching. So I'm just going to head back to EC2 here and find those nodes in my environment here. So it looks like I've got 3 T3 micro instances right here that are all in the running state. And so now we can kind of give these names so that we can uniquely identify which node in the cluster each of these is. So I'll call this one etcd01. I'll call this one etcd02. And for the third one, I'll just call it etcd03. Now keep in mind that this doesn't actually change the host name in the operating system itself. This is just a tag that's provided by AWS that allows me to uniquely track each of these resources. Later on, when we actually SSH into these virtual machines, we'll go ahead and change the host name of the actual VM to match the name tag that we've assigned here so that we have synchronicity between those values. So we'll go ahead and do that in the next video, but for now I'm just going to go ahead and verify that each of these nodes does have a public IPv4 address, and it looks like they all do, so I should be able to SSH into each of these. So in the next video, we'll go ahead and start the operating system level configuration to set up a high availability etcd cluster. I hope this has been informative for you, and I'd like to thank you for viewing.